So we look at the table. Hydrogen atom is not balanced. We have one atom on the reactant side and two atoms on the product side. Likewise, chlorine atom is not balanced. We have one atom on the reactant side, left-hand side, and then two of chlorine on the right-hand side. So we decide to start with any of them, hydrogen or chlorine. So let's choose hydrogen, where we place the cursor. We multiply that 1 by 2. You can see that. So we are increasing hydrogen to 2. We go back to the equation. Locate hydrogen on the left-hand side. You can see the cursor moving. Hydrogen is in the substance HCl. We now put 2 in front of HCl. And that makes chlorine now also to become 2. We go to the table and reflect it on the table. Hydrogen is 2. So chlorine is also 2. Move to chlorine. And then also apply chlorine by 2, making it 2. So by balancing hydrogen 2, we also balance chlorine as 2. So we go back to the equation and then check it again. Hydrogen is 2 atoms. Chlorine is 2 atoms. Magnesium is 1 atom. On both sides, magnesium is 1 atom on both sides. Chlorine is 2. On the left hand side is 2. 2 times 1 is 2. On the right hand side, chlorine is 2 on magnesium chloride. Then on the left hand side, hydrogen is 2 times on HCl, 2 times 1 is 2. On the right hand side is also 2 atoms, making hydrogen atom a balance, or making the equation a balanced equation. So having done that, we move to the next question. The next question is reaction between potassium and water. Potassium and water. So potassium is an element. So elements have symbol. Symbol potassium is K, water is H2O. We write the two substances on the left hand side because they are reactants and put a plus sign between them, showing that they are reacting. We draw an arrow to show the direction of the reaction. We now come back. Potassium, we bring it under. Potassium is element, and then its atomic number, which we have studied before, is 19. Is among the first 20 elements. The electronic configuration is 2 under the K shell, 8 under the L shell, another 8 under the M shell, and 1 under the N shell. So the valence electron or the atomos electron of potassium is 1, 2, 8, 8, 1. So being a metal, you're going to donate 1 electron out. So the valency is 1. So we put plus 1 there, that being the charge oxidation state. Water is split into H plus and OH, being the components of water. Then we now marry unlike terms together. We combine hydrogen positive with hydroxide. Valency of the two is 1, 1. Equal valency cancel each other. Combining them, we have KOH on this side. Then hydrogen ion is on its own, so free to move out. It moves out as a molecule, being diatomic, right? H2, not H or H plus, H2 on the product side. So we now check the atoms and check whether they are balanced. Potassium is 1 on the left hand side. Right hand side, you can see potassium there, 1 atom. On the right hand side, potassium is also 1 on KOH. Then hydrogen is 2 on the right hand side. Let's check. 2 on water, that is hydrogen is 2 there. Then on the right hand side, hydrogen is 3. KOH has 1 hydrogen, and then the molecule hydrogen has 2, so 2 plus 1 giving us 3. Then going to oxygen, oxygen is 1 atom on water on the left hand side. Then the right hand side, oxygen is also 1. So let's investigate the table. Now, which of the atom is not balanced here is hydrogen. Potassium appear to be balanced, 1, 1. Others appear to be balanced. Then what do? We now ask ourselves, which whole number we multiply 2 to give us 3? That is on hydrogen. Since hydrogen is unbalanced, which number will multiply 2 to give us 3? No number can do that. There's no whole number that can multiply 2 to give us 3. We now go to another element. Potassium is balanced. Oxygen is balanced. We run into a crossroad, into a confusion state. We don't know what to do again. Are we going to leave it like that? No. So since hydrogen is not balanced, even if I multiply the 2 here, hydrogen by 2, I will get 4, which is not equal to 3. If I multiply 3 again by 2, I'll get 6, which will not be equal to 4. So hydrogen is not balanced. We want to balance. So how do we tackle this kind of problem whereby you have one atom that is not balanced and other atoms are balanced? One atom that is not balanced, but the other atoms you have there are all balanced. What do? And you cannot balance the one that is unbalanced, that is hydrogen. It's not impossible to balance hydrogen. What you do is you unbalance any of the one that is already balanced, since there's nothing else you can do. So you can unbalance potassium, can unbalance oxygen by multiplying by 2. So then multiply that potassium by 2 to unbalance it. So we'll now go to the right hand side. Look at potassium. We'll put 2 in front of potassium. We'll go back to the product side. Potassium, we have to balance the potassium on the product side by multiplying this side by 2 to counter the other side. So we go to the product and put under 2 in front of potassium hydroxide. So that means potassium 2. Now, by putting 2 in front of KOH, we have increased oxygen to 2. So we'll go back to the product side. Oxygen is increased to 2. So multiply the oxygen there by 2. We still go back to the equation again. We still go look at KOH. So that 2 did not only affect potassium, it affected oxygen and also affected hydrogen. Hydrogen is 2 times 1, 2, plus this 2 here, which is 4. So go to the right hand side. Hydrogen that was 3, we want to change it to 4. We change it to 4 now. So having done that, remember what I said, once you put a number in front of any chemical compound, you have to change all the elements affected on the table before you start balancing another element again. So having balanced hydrogen now, or having effected a change on the right hand side completely, we start again with another element. We look at hydrogen on the left hand side now, 2. Right hand side we have 4. Oxygen on the left hand side 1. Right hand side we have 2. So we can decide to balance any of them. Let me start with hydrogen. I'll multiply these 2 by under 2, and that will make it 4. So I'll move to the equation and locate hydrogen. On the left hand side is in front of water. I'll put 2 in front of water. That balances hydrogen, and oxygen has now turned to 2 also on water. So I go to the equation and change oxygen to 2 atoms. By so doing, I balance the whole equation. 2, 2 for potassium, 4, 4 for oxygen, and 2, 2 for 4, 4 for hydrogen, and 2, 2 for oxygen. So you can cross-check the equation and see that it's balanced. 2 on potassium on the left-hand side, 2 on potassium that is on KOH, 4 on hydrogen on water, 2 by 2 is 4. Then on the right-hand side, hydrogen is on KOH, that is 2 of it, and then 2 on the molecule of hydrogen giving us 4. Then oxygen is on water, left-hand side, 2 times 1 is 2. Right-hand side on KOH, 2 times 1 oxygen there also gives us 2. So we have a balanced situation now. We'll now go to the next equation that says sodium chloride and terresophosphoric acid. So we have the compound. If you are confused or how the formula was obtained, you go back to the early part of the video where we studied or where we treated formula of ionic compound, how they obtained by valency exchange. So the formula of sodium chloride is NaCl. The formula of terresophosphoric acid is H2SO4. We split them into the components. Remove the first atom. The first atom in sodium chloride is sodium, Na, remaining chlorine. You get the valency of sodium. Sodium atomic number is 11. 2 under the K shell, 8 under the L shell, and 1 under the M shell. Having 1 in the large shell or in the outermost shell, which is also called valence shell, sodium is a metal because metals don't have more than 3 in their large shell. And being a metal, the valency is equal to the number of electrons in the large shell or outermost shell. It has 1, the valency is 1. So the charge of +1 shows the oxidation state. They put the sign there. Then chlorine is a non-metal, 287. 287, it needs to 17, that is 2 in the K shell, 8 in the L shell and 7 in the M shell. 2A7, it needs extra one to make that 7, or to call it non-metals electron acceptors. So valency of chlorine is that one requires to make the 7 electron in the atom shell to become 8. So valency is 1. Negative there shows the oxidation state or the charge. Then going to the next compound, H2SO4. What do we do to that one? Remove the first element, the first atom, hydrogen. Don't pick it, don't go with 2, just the element H. Then SO4 is the remaining component. SO4, that 2 you see close hydrogen, is the valency of SO4, it takes it back. So when you have done that, marry unlike terms together, unlike charges, sodium goes to SO4. And when they combine, you're forming a new compound. When they combine, there's going to be valency A change. So SO4 will donate 2 to sodium, while sodium will donate 1 to SO4. That should be a bracket before the 1 comes to SO4, and that one we know doesn't count. Formula now becomes N2SO4. Then joining hydrogen to Cl, valency is 1, 1 for the two of them. They will cancel being equal when I have HCl as their product. So let's look at the table underneath and see whether the equation is balanced or not. So we're going to judge whether it's balanced. We have this table. Sodium is 1 on the right hand side, 2 on the product side. Chlorine is 1 on the right hand side, 1 on the product side. Hydrogen is 2 on the right hand side, 1 on the product side. Sulfur is 1 on the right hand side, 1 on the product side. Oxygen is 4 and 4. When we look at the reaction, it appears that the only element that is balanced there is chlorine atoms and sulfur atoms. Chlorine, sulfur, and oxygen, whereas sodium and hydrogen are unbalanced. So what do? We work, or we'll start with one of them. So we'll look at sodium. We'll find a number that will multiply the smaller number, which is 1, to make it equal to the bigger number, make it equal to 2. So we can multiply by 2, because 2 times 1 is 2. So you see that. So we'll now go to the equation on the left hand side. This is where you have sodium, and we'll put 2 in front of sodium to balance it. We have 2 there, and by putting 2 in front of sodium, we have increased chlorine also to 2. Chlorine also becomes 2. So we'll go to the equation, to the table, and make a change so that chlorine will also become 2 on the table on the left hand side. So we'll multiply this place, chlorine, by 2 also, and by doing that, we have also unbalanced chlorine. So chlorine is 2 on the left hand side now, on the right hand side is 1. So to balance chlorine on the right hand side, what do? We go to the right hand side and multiply chlorine atom also by 2, so that we can have a balanced situation. We'll now go to the product side and put on HCl, we have chlorine. We put 2 in front of chlorine, or in front of HCl, and that will make hydrogen on this side to be equal to 2 also, because that 2 affect both hydrogen and the chlorine. We'll come back to the table so that we effect the change on hydrogen. Now becomes times 2 there. So they change the equation. We see that from the table, we have a balanced situation. 2 of sodium on both sides, 2 of chlorine, 2 of hydrogen, 1 of sulfur on both sides, and 2 of oxygen. So let's go back to the equation and check. We have 2 of sodium on sodium chloride. We have 2 of sodium on NaSO4. We have 2 of chlorine on sodium chloride. We have 2 of chlorine on HCl. We have 1 of sulfur on the left hand side, 1 of sulfur on the right hand side, 4 of oxygen on HCl4, 4 of oxygen on Na2SO4. That means we have a balanced situation here. We have balanced the equation. We'll go to the fifth reaction. or equation that says we have triosonitrate 5 acid and potassium triosocarbonate 4. First of all, again, as we used to do normally, we have to get the right formula of the reactants. Triosonitrate, tri means 3 oxygen, nitrate indicates nitrogen, that's NO3 as in there. You calculate the charge of the radical, which is -1. You have been taught how to do it earlier on in this video. Then an acid, as we said, acids contain hydrogen ion. So the hydrogen there, ion should be there because of the word acid. And then the charge of hydrogen is +1 in acids. So you change valency, NO3 donates 1 to hydrogen, hydrogen donates 1 to NO3. The bracket should be there because hydrogen is donating to a radical, a group of atoms. So 1 cancels. The formula is HNO3. You go to the other substance. Potassium is a metal. Atomic number is 19. If you share the 19 in the shells, K share takes 2, L share take 8, M share takes 8, and then N share takes 1, as we have studied previously. And having not up to 3 in the atomos share, or not more than 3, makes potassium a metal. And the valence of potassium is nothing but the valence electron. Valence electron, I will repeat again, is different from valency. But in metals, valency and valence electrons are equal. So 1 here. And then the triosocarbonate 4. Trioso is O3. Then carbonate indicates carbon. This is the radical. The valency is 2. So charge is -2. You have been taught how to calculate it from the table on radicals. So you have valency change. Keep the formula ready. 2 from CO3 goes to potassium. And 1 from potassium goes to CO3 radical. You have a bracket before the 1 comes in. And that 1 has no influence, has no effect. Because why doesn't 1 have effect? 1 times carbon, 1 carbon inside is the same 1. 1 times 3 is the same 3. So that 1 is thrown away regardless. So you come to the equation now. You write the reactants on the left hand side, HNO3 plus K2CO3. Then you split HNO3, remove the first atom, hydrogen, the remaining goes together. NO3, put their valencies, remove the first atom, K. Remember, I did not go put K with 2, just put the atom symbol K. Then CO3, that 2 close to K is the valency of CO3. You can see the 2 minus there. Just like it's something as you are redoing what you did before, splitting it back to H and NO3 and then K and CO3 2 minus is something that we did there. Then marry unlike charges. Potassium goes with NO3. They have equal valencies. 1 cancels. If not, the valence would have been a change. So KNO3 is the formula of the compound. And then H goes to CO3. When they combine, they're going to be a change of valency. The CO3 will donate 2 to H, giving you H2CO3, as you can see written down there. But H2CO3 is an unstable product, so that is why it is not written on the product side. So H2CO3 is unstable, easily splits. It splits into water and CO2. So that is why on the product side we have water and CO2 in place of H2CO3. So you can see, so when H2CO3 is formed as a product, you split it into water and CO2. So having done that, let's go to the table. Check the balancing. Potassium is 1 and 2 the other side. Carbon is 1 on both sides. Oxygen is 6, hydrogen is 1 2. So that hydrogen and potassium are not balanced. So you start with either hydrogen or start with potassium. So let me start with hydrogen. This side, the product side of potassium, start with potassium, sorry. The product side of potassium is smaller, 1. So to increase it, I multiply that 1 by 2. So go to the equation, look at the product where you have potassium. I'm going to put 2 in front of potassium. And that 2 you put in front of potassium will affect nitrogen and also affect oxygen. So this is our nitrogen. Nitrogen becomes 2. We go to the table and change nitrogen. So, is there any error there? So we did not put nitrogen. Okay, look at nitrogen. On the product side is 2 now. So multiply this nitrogen on this side by 2. That will increase nitrogen. You go back to oxygen, to the equation. Oxygen is also affected. Oxygen is now 2 times 3 is 6. 6 plus 2 times 3, that is 3 in KNO3. Multiply by the 2 in front, that is 6. Plus 1 oxygen in water, that gives you 7. Then plus 2 oxygen in CO2, that gives us 9. 6 plus 1 plus 2, that gives us 9 oxygen atoms. So come to the equation and change the oxygen from 6 now to 9. So having done that, so having changed the atoms affected, we'll continue again with the balancing. We have carbon. We cannot balance oxygen easily because no number will multiply 6 to give us 9. So it's not easy to balance oxygen. We run away from oxygen. We go to hydrogen. You look at hydrogen, 1 and 2, that'll be easier. We multiply the smaller side 1 by 2 to balance hydrogen. We go to the equation. On the left hand side, we have hydrogen and put 2 in front of HNO3 to balance hydrogen. But you look at that substance, HNO3 contains other elements. So nitrogen is going to become 2 now, no longer 1. So 2 times 1, there is 2. Go to the left hand side of the table and change nitrogen to 2, multiply by 2 now. We go back to the equation again. Apart from hydrogen, then oxygen is also affected. Oxygen is now 2 times 3 in HNO3. 2 times 3 is 6. Then on K2CO3, there is 3 oxygen there. So 6 plus 3 gives us 9. We go to the equation and change oxygen to 9. Having done that, we have a balanced situation. Potassium is 2, 2 on both sides. Carbon 1, 1, oxygen 9, 9, hydrogen 2, 2, and nitrogen 2, 2. You can change the equation. In the equation, hydrogen is 2 atoms on HNO3. On the other side, on water, hydrogen is also 2. Then, and on HNO3, nitrogen is 2. That's 2 times 1. On the other side, on KNO3, 2 times 1 is also 2 for nitrogen. Then oxygen, on the left-hand side, 2 times 3 for in HO3, 2 times 3 is 6. Then in potassium carbonate, there is 3 there. 6 plus 3 gives us 9. On the other side, in KNO3, 2 times 3 is 6. 6 plus the 1 in water is 7. Then 7 plus 2 also 9. Carbon is 1 on CO2. And on this side, in K2CO3, carbon is also 1. So we have a balanced situation now. The next reaction is copper 2 triosonitrate 5 and sodium hydroxide. So the formula of the compounds are there. We have the formula of copper 2 triosonitrate 5. In that formula, copper is bit oxidation state of +2, while NO3 has state of -1. So when you change valence of copper 2, when you give that valence of copper 2 to NO3, you get the formula CuNO3, Cu bracket NO3 bracket 2. Then this is the formula of sodium hydroxide. Sodium has valency of 1 and hydroxide have valency of -1. So you have the right formula. Then you write the two reactants on a straight line with a plus sign between them. And when you are done that, you now split them into their components. Remove the first atom, copper. The other remaining component is NO3. And copper has the 2 that is close to NO3. So copper takes back its charge or valency. Split Na from OH and put the appropriate valencies. Sodium is +1, hydroxide is -1. The marry unlike terms. Copper attracts negative OH. And when they come together, valencies they change. So the 2 from copper goes to OH, bracket before the bracket, then the 2 comes out the bracket, now have copper 2 hydroxide. Then the sodium attracts NO3, plus and minus equivalency 1, 1 cancel. So NaNO3, that's the product obtained. So when you marry unlike charges or when you bring unlike charges together, make sure you change the valencies appropriately. So having done that, we'll now look at the product. So having done that, we'll now look at the table. Copper will have one atom of copper on the left hand side, right hand side, and one atom of copper on the right hand side. We check the equation. We have copper one atom there on copper nitrate. Product side, we have one atom of copper on copper hydroxide. Then nitrogen is 2 on the left hand side, 1 on the right hand side. We go to the table equation. We have on the reactant copper nitrate, you have 2 of nitrogen, that the 2 after the bracket multiplied by the 1 of nitrogen inside gives you 2 nitrogen. Then on the right hand side, nitrogen is only 1 on sodium nitrate, NaNO3. Then oxygen is 7 on the left hand side and 5 on the right hand side. We check. Then look at copper nitrate, 2 times 3 inside gives you 6. Then on sodium hydroxide, 1 oxygen, so 6 plus 1 gives us 7 oxygen atom. On the right hand side, on copper hydroxide, 2 times 1 of oxygen inside gives us 2, plus the 3 as in sodium nitrate gives us 5. Then we go to sodium. Sodium is 1 on both sides. We go to the equation. In sodium hydroxide, sodium is 1 atom. Then in sodium nitrate, sodium is also 1 atom. Then hydrogen is 1 on the left hand side here and 2 on the right hand side over there. So you go to the reactant. On some hydroxide, we have only 1 hydrogen atom. In copper 2 hydroxide, hydrogen is 2 because that 2 outside apply both hydrogen and oxygen differently. So hydrogen is also 2 atoms. So the equation is not balanced because some atoms there are not balanced. Atoms like nitrogen, oxygen, and hydrogen. So we'll start with the ones that are possible for us to balance. We can start with nitrogen, which has 2 and 1. We're going to increase that 1 by a factor of 2. Multiply it by 2, we're getting 2. So we go to the product. That is how we increase. We locate nitrogen on sodium nitrate. There you have nitrogen. You put 2 in front of the substance. So you have NaNO3. So that 2 will not only affect nitrogen, it will still affect sodium and oxygen. So sodium is 2 on the left hand side, or 2 times 1 is 2. There is no sodium in this substance. So 2 sodium atoms. So you go to the table and then change sodium. You see sodium on the right hand side. We multiply that 1 by 2. Sodium becomes 2 now. Now which other element is affected? Another element affected there is also oxygen. Because oxygen becomes 2 times 3, 6. And there's also another oxygen here. Oxygen here is 2 times 1, 2. So 6 plus 2 gives us 8 oxygen atoms. We go to the table and change this 5 to 8. Oxygen now becomes 8. So having effected a change on the right hand side, we'll go to another element. Which element is not balanced again? Nitrogen is not. Copper is balanced now. Nitrogen is balanced. Oxygen is not balanced. But when I look at 7 and 8, is there any whole number that multiply 7 to give us 8? There's none. So go to check for another element. Hydrogen is there, 1 and 2. So I think hydrogen is easy to be balanced. So go to hydrogen, multiply the smaller number 1 by 2. Having done that, we have increased the right hand side or left hand side. Look at hydrogen on the left hand side. So you can see hydrogen on sodium hydroxide. So place the cursor in front of that substance and put 2. That makes hydrogen now 2. But remember that by putting 2 there, sodium will turn to 2 now. Go to the left hand side, right hand side, and change sodium. You can see sodium there to 2. Also, by putting 2 in front of sodium hydroxide, we are affecting oxygen. Oxygen becomes 2 in sodium hydroxide, and this side becomes 6. 2 times 3 is 6. So 6 plus 2, 8. So on the left hand side, oxygen has turned to 8. Go to the table and change oxygen atom to 8. So we have effected a change. We check the table again. The copper is 1, 1 on both sides. Nitrogen is 2, 2 on both sides. Oxygen is 8, 8 on both sides. Sodium is 2, 2 on both sides. Hydrogen is 1, 1 is 2, 2 on both sides. So we'll now have a balanced situation. check the right hand side. Copper is 1 on the product side, copper is also 1. Check the right hand side. Nitrogen is 2. 2 multiplied by the 1 inside bracket on copper nitrate, that gives you 2. On the right hand side, nitrogen, look at sodium nitrate. 2 multiplied by the nitrogen inside, that also gives you 2. Right hand side, check oxygen. 2 times 3 is 6. There's another oxygen here. 2 times sodium hydroxide, 2 times 1 is 2. So 2 plus 6 is 8. Go to the right hand side. On copper hydroxide, 2 times 1 for oxygen there is 2. And then in sodium nitrate, 2 times 3 is 6. 6 plus 2 also gives you 8. So you see, go to this one. Sodium is 2 atoms here. 2 times 1 is 2. Sodium is also 2 atoms here. Hydrogen is 2 times 1. Right hand side, 2 times 1 on sodium hydroxide, 2 times 1 is 2. Then product side on copper hydroxide, 2 times 1 is also 2. So that confirms that the equation is a balanced equation. So having done that, we'll now look at miscellaneous problems on how to balance equations. So we'll look at miscellaneous problems. Number 1 says, balance the equations below by finding the missing letters S and Y in each case. So number 1, we have an equation which involves S molecules of nitrogen 4 oxide NO2 plus Y molecules of sodium hydroxide NaOH, giving us 1 molecule of sodium diisonitrate 3, 1 molecule of sodium triisonitrate 5NO3, and 1 molecule of water. So we have to look for S and Y. So that S covers the number of atoms of nitrogen and oxygen. Y covers number of atoms of sodium, oxygen, and hydrogen. So what do? We look at, that means the left hand side is not balanced, the right side is not balanced. We look at the right hand side, the product side. The product side appears to be balanced because if you look at the product side, the substances there, NaNO2, NaNO3, and water, H2O, have no letters in front of them. That means the right hand side is balanced, the product side is balanced. So let's count the number of sodium on the right hand side. Sodium atom in NO2 is 1 atom. In NaNO3, another 1 atom. That makes it 2. 1 plus 1, 2. In water, there is no sodium in water. So on the right hand side, there are 2 sodium atoms. Na in NO2, 1 sodium, and also 1 sodium in NO3. So we'll now go to the right hand side. Where do we locate sodium? Sodium is in NaOH. That means if sodium should be 2 on the left hand side, that implies that Y is 2. We will go to Y and replace Y with 2. That balances sodium. So we'll now look at S. S takes care of nitrogen and also oxygen. So go to the left hand side. You look at nitrogen. Nitrogen is 1 atom in NaNO2 and 1 atom in NaNO3. That means nitrogen is 2 on both sides. On the product side, 1 atom in this one, NaNO2, and 1 atom in NaNO3. There is no nitrogen in water. That means the value of S should be 2 to balance nitrogen. So S should be 2. So to confirm our answer, let's cross check again. Nitrogen is 2 on this side. On this side, nitrogen is in the first compound, the NaNO2, nitrogen is 1. NaNO3, nitrogen is another one, making it 2. Then we'll go to this side. Oxygen on this side, 2 times NO2, 2 times 2 is 4. In NaOH, 2 times 1 is 2. So 2 plus 2 gives you 4. Oxygen on the left hand side. On the right hand side, in NaNO2, oxygen is 2. In NaNO3, oxygen is 3. Units 5 plus 1, 6. Let's go back. There could be an error somewhere. Okay, let's repeat again. In NO2, oxygen is 2 times 2, 4. 4. NO2, that is 2 multiplied by 2, 4. In NaOH, oxygen is 2 times 1, 2. So 2 plus 4 give us 6 on the left hand side. On this side, oxygen is 2 in the first compound, NaNO2. Oxygen is 3 in this one, NaNO3, giving us 5. Oxygen is 1 in water, giving us 6. So oxygen is balanced as well. We go to sodium. Sodium is 1 times, is 2 in the other, is 2 in front of sodium, 2 times 1 is 2. On this side, sodium is 1 in NaO2 and also 1 in NO3, giving us 2 atoms. Then going to hydrogen. Hydrogen is 2 times 1, 2. There's no hydrogen on this one. There are 2 hydrogen atoms here. We go to the right hand side. Hydrogen is also 2. That means balance. That means S is 2 and Y is also 2. It's a balanced equation. Now going to question number 2. We have to find S in front of water. SH2O. We go to, and that S covers hydrogen and also oxygen. We go to the right hand side. You see that on the right hand side, all the atoms there are balanced. How do you know they are balanced? Because there are no letters in front of the substances. So let's count the hydrogen on this side. Hydrogen is 2 on this compound. There is 2 times the 1 in bracket giving us 2, and then 2 they are giving us 4. So hydrogen is 4 on the right hand side. So let's go back. There is no hydrogen on calcium. This is where we have hydrogen. So what number are we going to replace S with so that we can get hydrogen as 4? What we do is we remove the S and divide the 4 by 2. So the S should be 2. S should be 2 because 2 times 2 gives us 4. So because hydrogen is 4 this side, so S should be not 4, S should be 2. We divide the 4, we obtain hydrogen here by the hydrogen atom here, which is 2 in water. That gives us 4. So 2 times 2 gives us 4. We have 4 hydrogen this side and also 4 hydrogen on the other side. If you check oxygen in water, 2 times 1, oxygen is 2. And then in calcium hydroxide, 2 times 1 inside the bracket is also 2. So the equation is balanced. So S is 2 as solved here. So look at this question number 3. So you make attempt on the question S Zn bracket NO3 bracket 2 Y ZNO plus ZNO2 plus oxygen. So you pause the video. You can pause the video and then solve this. Find S, Y, and Z. And then after that, then you go back to the video and continue and see whether you have the answer right. So let's go to the solution. So we go to solution. So we have S as 2, we have Y as 2, we have Z as 4. Is that correct? Let's find out. Zinc is 2 atoms, that is 2 times 1 of zinc in front of the zinc nitrate, that gives us 2. Here zinc times 2 times 1 of zinc in zinc oxide also gives us 2 on the product side. Nitrogen is 4. How did I get 4? 2 after the bracket times 1 of nitrogen inside gives us 2. And that 2 in bracket multiplied by the 2 in front of zinc gives us 4 nitrogen. On this side, nitrogen is 4 times 1 in front of NO2 gives us also 4. On this side, oxygen is 2 times 3 in the bracket is 6. Then times 2 in front of zinc, that gives us 12. On this side, oxygen in zinc oxide, the first compound, there are 2 times 1 of zinc. Oxygen is 2. In NO2, 4 times 2 is 8. So 8 plus the 2 got there is 10. Then plus these 2 on that side, that gives us 12. So you see we have a balanced equation. Then going to example 4. Copper plus S molecules of silver nitrate gives us copper nitrate plus Y molecules of zinc. To balance this equation, what do we do? It may not be difficult. You see that S covers silver, covers nitrogen, and covers oxygen. So out of these 3 atoms, silver, nitrogen, and oxygen, which of the atoms is balanced on the right hand side? Silver is not balanced, so we don't know the number in front of silver. Another element there is nitrogen. Nitrogen is balanced because copper nitrate has no substance in front of it. That means the number of atoms of nitrogen on the right hand side is just 2. There is 2 after the bracket. Multiply by the 2 inside, that gives us 4 atoms of nitrogen. So we'll now come and replace S by 2. That means S is 2. So if S is 2, that will still make our silver atom to become 2 atoms of silver. On the left hand side, we are balanced silver now. So on the right hand side, we replace Y also by 2 to balance silver. Replace Y by 2. We now have a balanced equation. So you check very well. Copper is 1 atom on the left hand side. Copper is 1 on the right hand side. Silver is 2 atoms on the left hand side, 2 on the right hand side. Nitrogen is 2 times 1, 2 on the left hand side. Right hand side, in the bracket, 1 of nitrogen times 2 outer gives us 2. Oxygen on the left hand side, 2 times 3 is 6. Right hand side, on copper nitrate, the 2 outside times 3 in bracket gives us 6. So we have a balanced equation. We go to question number 2. Question 2 says, balance the equation below. We have iron reacting with oxygen to give us iron 3 oxide. Iron reacting with oxygen giving us iron 3 oxide. How to balance it? By inspection. You see that iron is 1 atom on the left hand side, but 2 on the right hand side. So we will be tempted to put 2 in front of iron on the left hand side, so that we'll have 2 on the left hand side and 2 on the right hand side. So you see it's no balance. Now when I look at oxygen, oxygen is 2 on the left hand side, but 3 on the right hand side. The right hand side has a bigger number 3, while the left hand side had a smaller number 2. Remember, we already balanced iron. So iron is 2, 2, but remaining oxygen 3 and 2. 3 is an odd number, so there's no number that can multiply 2 to give us 3. No whole number can do that. So you know that the equation is now complex for us to balance. So what do we do? How to tackle this problem? And we'll know that we'll balance every other element except oxygen. What then do we do? Since 2 cannot divide 3 unless we remainder. If I use 2 in front of oxygen, 2 times 2 is 4, and it can't give me 3. And mind you that any number I put in front of iron will now change the iron and make it unbalanced. So what I can do is I can apply fractions. It's possible. So one number, if I use this 2 divide the 3 there, I'll have 1.5. So I can put 1.5 in front of oxygen. So we now have 1.5 there in front of oxygen. And you know that John Dalton told us that atoms usually combine in whole number ratio. So we don't normally use fractions or decimal. But if you look at 1.5, 1.5 times 2 still give the same 3. So what we'll do is we're going to convert this ratio to whole number. What we'll do is we'll multiply the whole stoichiometric ratios to 1.5 and 1 on the other side by 2. So which is the smallest number we can use to balance the equation. Apply to 1.5 by 2. Look at what I mean. I'll use 2 to multiply everything. A bracket there. Error. So you multiply the whole equation by 2. So you can see 2 have outside the bracket. Multiply the stoichiometric ratios to 1.5 and 1 more by 2 to convert that 1.5 to a whole number. So 2 multiplying 2 will give us 2 in front, multiply the 2 in front of iron, give us 4. So we now write So multiplying the whole number of moles iron by 2. There is 2 moles of iron there by 2, so that we can cancel out convert the 1.5 to whole number. So multiply 2 of iron by 4, by 2, sorry, going to give us 4. So we change it to 4. We now have that. Multiply the 1.5 also by the 2, we have 3. Change it to 3. Multiply this 1 mole of iron 3 oxide by 2, we have also 2 there. So multiplying 1 mole of iron 3 oxide by 2, have 2. So we can repeat the process again. We go back to the main equation. We have the equation we have to balance this equation. And when we look at it, iron is having 1 atom on the left hand side and 2 on the right hand side. So our first instinct is to balance iron by putting 2 in front of iron. Then, having done that, we look at oxygen, which is the other element minimum balance there. Oxygen is 2 atoms this side and 3 atoms on the other side. To balance oxygen, there's no number that can apply 2 to give us 3. No whole number can do that unless we apply fractions. So what do? We can divide 3 by 2, and that will give us, divide the number of oxygen in the atom there, 3, by the smaller one, that is 2, give us 1.5. We now write 1.5 in front of oxygen. So we have it there. If you check the equation, it's already balanced. 2 moles of iron on this side, 2 moles of iron on the other side. You can see that. Oxygen 1.5 times 2 is 3. I will have 3 there. But since we normally balance equations with whole number, we're going to multiply 2, 1.5, and 1. The stoichiometric ratios by 2. You use 2 to cancel the decimal value. So multiply 2 this side by 2, I'll have 4. I multiply 1.5 here by also the same 2, I'm going to have 3. I multiply 1 mole of iron oxide this side by 2, I have 2. So we have a balanced equation now. You can see 4 atoms of iron on this side. 2 times 2, that gives us also 4 of iron. Oxygen 3 times 2, 6. Then this side 2 times 3, also 6. And that balances the equation. Number 3 question says we should write a reaction between carbon 2, or the equation between carbon 2 oxide, CO, and hydrogen to give methyl alcohol. So what it means is that carbon 2 oxide and hydrogen are the reactants, while methyl alcohol, otherwise known as methanol, is the product. You follow the format of writing the equations, put the reactants on the left hand side with a plus sign between them, and the product on the right hand side. We now balance the equation. We'll check this substance, 1 carbon on the left hand side, 1 on the left hand side, and 1 on the right hand side. So carbon is balanced. We look at oxygen, 1 atom on the right hand side and 1 on the left hand side. Oxygen is balanced. We look at hydrogen, 4 atoms on the left hand side, 3 plus 1, that is 4, and 2 on the right hand side. So this side is bigger. We divide the 4 by 2, and that will give us 2. So we need to place 2 in front of hydrogen. We have it there. So we now have a balanced equation for that reaction. That's well written now. We now go to question number 4. Number 4, we have that equation. We ask balance the following chemical equation. Aluminium plus oxygen giving us aluminium oxide. This is more like the one we did on number 2. Now to balance this equation, first of all, look at aluminium. I have 2 atoms here and 1 atom. So let's go to the solution. For aluminium, 1 atom here and 2 atoms of aluminium on this side. So what would I do? I go to the left hand side that is deficient and put 2 in front of aluminium, and that balances aluminium. And look at oxygen. I have 3 atoms on this side, but only 2 on this side. So oxygen is deficient on the left hand side. But there's no number that can multiply 2 to give us 3. What do we do now? Since it's remaining only oxygen, we divide that 3 by the 2. So 3 by 2 will give us 1.5. We put 1.5 in front of oxygen on the left hand side. If you check, it is balanced. Why is it balanced? 2 of aluminium on the left hand side, 2 of aluminium on the right hand side. 1.5 times 2, that is 3 of oxygen on the left hand side, 3 of oxygen on the right hand side. So it's balanced, but we need to convert the decimal value to whole number. Multiply everything, the stoichiometric ratios, to 1.5 and 1 mole by 2. So multiply all the numbers by 2, multiply 4 by 2, you multiply 2 by 2, you get 4, multiply 1.5 by 2, multiply 1.5 by 2, you get 3. There. Then multiply 1 mole, 1 in front of aluminum oxide, by 2, you get also 2. So the equation is balanced. You can check very well. 4 atoms of aluminum on the left hand side. Right hand side, 2 times 2 is 4. Oxygen, 3 times 2 is 6. And the other side, 2 times 3 is also 6. This is a balanced equation. Go to the next example. Nitrogen plus hydrogen giving us ammonia. Is not a balanced equation. If you look at it, nitrogen is 2 on the left hand side and 1 on the right hand side. Hydrogen is 2 on the left hand side and 3 on the right hand side, so it's not balanced. We go to the solution. What do we do? The first thing that we look at nitrogen, we have 2 on this side, we have 1 on this side. So this side is smaller. We put our cursor on the left hand side in front of ammonia. We can put 2 in front of that, becomes 2 nitrogen. We balance nitrogen. We now look at hydrogen. 2 times 3, this side is 6. And then in front, in the right hand side, we have 2. So is there a number that can apply 2 give us 6? So we have 6 here. So is 6 divisible by 2? Yes. So 6 hydrogen atoms here divided by 2 here gives us 3. So we should have 3 hydrogen atoms, 3 moles in front of the reactant. So we check the balancing. Nitrogen is 2 atoms on the left hand side. The right hand side, 2 times 1 on ammonia is also 2. Left hand side, 3 times 2 for hydrogen is 6. Right hand side, 2 times 3 gives us 6. It's a balanced equation. We go to question C. Question C, we have aluminium plus chlorine giving us aluminium chloride. It's not a balanced equation. Aluminium 1 atom, chlorine 2 atoms on the left hand side, aluminium 1 atom on the right hand side, chlorine 3 atoms. So it appears that chlorine is not balanced. We see that chlorine is not balanced. So you look at the solution, aluminium is already balanced, but chlorine is not balanced. 1 atom of aluminum on both sides. Then look at chlorine. We have 2 atoms on the left hand side and 3 atoms on the right hand side. And then 2 cannot divide 3 unless remainder. So we divide 2 by 3, we have only 1.5. Remember that we have only chlorine to balance. We already have aluminum balance. So to balance chlorine, we need to put 1.5 in front of chlorine on the left hand side or reactant side. So 1.5 there. Okay, it should come here. The solution 1.5 on this side. So that's the solution there. Go. Okay. So having done that, we have balanced the chlorine atoms because 1.5 times 2 gives us 3, which is what we have on the right hand side. But we need to convert that decimal value to whole number by multiplying the stoichiometric ratios. 1 mole in front of aluminium, 1.5 in front of chlorine, and then 1 mole in front of aluminium. We multiply everything by 2. So multiply aluminium here by 2. We have 2 there. Then multiply 1.5 by 2. We're going to have 3. multiply 1 mole of aluminum chloride by 2, we're going to have 2. So we check it, we now have a balanced equation. 2 atoms of aluminum on the left hand side, 2 atoms of aluminum on the right hand side. 3 times 2, 6 atoms of chlorine on the left hand side. 2 times 3, 6 atoms of chlorine on the right hand side. We look at the third equation. We have a boron 3 oxide reacting with hydrogen fluoride, giving us boron fluoride and water. We have to balance the equation, and we will now go to the solution. The solution that is down there. We start with boron. Boron is 2 atoms on the left hand side. On the right hand side, we have only 1, so we have to put 2 in front of boron. So you can see that the boron is balanced now. Then we'll now go to oxygen. Oxygen is 3 atoms on the left hand side. On the right hand side, we have only 1 atom in water. So we'll try to put 3 in front of water to balance oxygen. Having done that, we'll now go to hydrogen. Hydrogen is 1 atom on the reactant side on HF. Then on the left hand side, hydrogen is 6. 3 times 2 on water is 6. So we'll try to put 6 in front of HF on the reactant side, that is HF. That will now go to fluorine. Fluorine is 6 atoms on HF, because 6 times 1 there is 6. On the right hand side, on BF3, 2 times 3 is also 6. So fluorine is a balance. We go to equation E. We have magnesium oxide plus iron, giving us iron 3 oxide plus magnesium. We now go to the product. Solution. Magnesium is 1 atom on the left hand side, 1 atom on the right hand side. Magnesium is balanced already. So back to oxygen and iron. Oxygen is 3 atoms on the left hand side. On this side, we have only 1 atom on magnesium oxide. So put the cursor in front of this and put 3 to balance oxygen. And by so doing, we have increased magnesium to 3 also. So go to the left hand side, right hand side, the product, and in front of magnesium, put the cursor there, and also put 3 in front of magnesium. Having done that, oxygen is 3, magnesium is 3. Then we look at iron. Iron is 2 on the left hand side and 1 on the right hand, 2 on the right hand side, that is product side, and 1 on the left hand side. We'll put 2 in front of iron to balance iron. So let's cross check the equation again. Magnesium is 3 on the left hand side, the right hand side, 3 on the product side. Oxygen is 3 on the left hand side, and then 3 on the right hand side. Iron is 2 atoms on the left hand side and 2 on the right hand side. So it's a balanced equation. We'll now go to another kind of reaction called combustion reaction. Combustion, when substance is born in oxygen, we say that the substance has undergone combustion reaction. So in chemistry, we say this is a reaction of a compound with oxygen in which all the elements of the compound combines with oxygen. A typical example of combustion of this reaction is the combustion of hydrocarbons. And in chemistry, hydrocarbons are compounds that contain only carbon and hydrogen. Example there is combustion of methane. Methane is CH4 combined with oxygen to produce carbon dioxide and water. We look at the equation, is it balanced? We have 1 atom of carbon on the left hand side, 1 of carbon on the right hand side, 4 of hydrogen on the left hand side, but 2 of hydrogen on the right hand side, so it's not balanced. So how to balance it? We start with hydrogen. Let's go to this. The solution under, there is 4 of hydrogen on the left hand side and only 2 on the right hand side. So we'll go to this side that is smaller. The number that we ought to put here is 2 to balance the equation. That becomes 2 times 2, 4. Let's check oxygen. On the right hand side, product side, oxygen is 2 on CO2 and 2 on water. 2 times 1, that is giving us 4. 4 of oxygen on the right hand side. So, but on the left hand side, we have only two atoms of oxygen. We have to put 2 in front to balance the oxygen here. That gives us 2O2. So if we check again, carbon is 1 on the left hand side in methane CH4, 1 on the right hand side in CO2, 1 carbon. Hydrogen is 4 in methane, and then on the product side, 2 times 2, that is in water, I have 4. Oxygen is 2 times 2, 4 on the left hand side. Then right hand side, you have 2 in CO2. Then 2 times 1, 2 in water, 2 plus 2 gives you 4. We have a balanced combustion equation for methane. Another example of combustion equation is combustion of a compound called octane. So let's see how this one goes. Octane is how this one goes. Octane is C8H18. That's octane. Combustion means combine with oxygen and giving you CO2 and water. So when hydrocarbons bond, you're going to get CO2 and water is a fixed product. So let's see how to balance it. Carbon is 8 on the left hand side of, that is on octane. On the right hand side, carbon is only 1. So what do? We put 8 in front of carbon to balance, or in front of CO2 on the right hand side, balance carbon. Then looking at hydrogen, hydrogen is 18 on the left hand side. On the right hand side, we have only 2. To balance hydrogen, I'm going to put put 9 in front of water, because 18 divided by 2 is 9. That gives 9. 9 times 2 give you 18. So I balance carbon 8 on both sides. I balance hydrogen 18 on both sides, remaining oxygen. Oxygen is 2 on the left hand side, right hand side. But on the product side, oxygen is on CO2, 8 times 2 is 16. And then in water, 9 times 1 is 9. So 16 plus 9 will give us 25. And what's remaining to be balanced is only oxygen. We have balanced every atom. So 25, we have 2 of oxygen on this side. So 25 is not an even number. So 2 cannot divide 25 unless remainder. So what we now do, we employ fraction. So divide 25 by 2, that will give us 12.5. So I'm going to write 12.5 in front of oxygen. So to have an equation, 12.5 for oxygen. And as we said, we don't normally use decimal to balance. We have to convert everything to whole number. So I'm going to multiply the stoichiometric coefficient, 1 mole in front of octane, 12.5 in front of oxygen, 8 in front of carbon dioxide, and 9 in front of water. Multiply everything by 2. So if I multiply 1 mole by 2, I'll get 2 here. If I multiply 12.5 by 2, I'll get 25 there. If I multiply CO2, 1 mole by 2, okay, 8 moles up by 2, I'll get 16 on CO2. If I multiply 9 for water by 2, I'll get 18. So I should have a balanced equation now. So I'll cross check. Carbon is 8 times 2, 16 on the left hand side. This side, 16 times 1 on carbon dioxide is 16. Hydrogen is 2 times 18, that is 36. On this side, 18 times 2, that is also 36. Oxygen is 25 times 2, that is 50. On this side, 16 times 2 is 32. 18 times 1 in water is 18. So 32 plus 18, that will give us 50. So that's a balanced equation for the combustion of octane. We now look at further exercise that says the combustion of boron 5 hydride B4H10 in oxygen to give boron oxide and water, boron trioxide and water. So we have to write the equation for this reaction. So since boron hydride and oxygen are the reactants, as we normally do, write them on the left hand side with a plus sign between them. And we're given the product already. The products are boron trioxide and water. We'll write the products on the right hand side. So this reaction involves 2 reactants and also 2 products. So we have to start balancing the equation. So we'll go into the business of balancing the equation. What do? Let's start with boron. Now, boron is 4 atoms here. This is the first equation shows the question anyway. Then we'll go to the second equation to imply to start balancing. So boron is 4 atoms here on the left hand side and 2 on the right hand side. So I will put 2 in front of B2O3 to balance boron. Then 4 boron atom on the right hand side now and 4 on the right hand on the left hand side. Then hydrogen is 10 atoms on the left hand side, while on the right hand side hydrogen is 5 atoms. So hydrogen is 2 atoms, sorry. I'll put 5 in front of hydrogen, in front of water. That means hydrogen 10, and the left hand side is already 10. What remains now is oxygen. Our balanced boron. Our balanced boron is 4 on both sides, 4 on the hydride, and then 4 on the other side. 2 times 2 is 4. Hydrogen is 10 on the hydride, and this side 5 times 2 is 10. So what remains to balance is oxygen. Now we'll go to oxygen is 2 on the left hand side, which is small. Then on the right hand side, 2 times 3 is 6 on the other side. The boron other side, 2 times 3 is 6. On water, 5 times 1 is 5. So 5 plus 6 give us 11. And 2 divided 11 will not give you a whole number, because 11 is an odd number. So 2 into 11 will give you a fraction, which is 5.5. So I'm going to write 5.5 in front of water. So as we do, when we see a fraction or a decimal value is involved, we multiply everything by 2, or the stoichiometric ratio by 2. So the number in front of boron hydride is 1, multiply by 2, get 2 here. Number in front of oxygen is 5.5, multiply by 2, get 11. Number in front of boron hydride is 2, multiply by 2, you get 4. Number in front of water is 5, multiply by 2, you get 10. So let's check the equation again. Boron atom is 10, 2 times 4, 8 on the left or hand side or right hand side. On the right hand side, 4 times 2 is 8 also. Then hydrogen is 2 times 10 is 20. On this side, 10 times 2 in water is 20. Then oxygen is 11 times 2, 22 on the left hand side. This side, on the first compound, the other side, 4 times 3 is 12. The other one, 10 times 10 is 20. So 20 plus 12 will give you 20. 20 plus 12 give you 22. So that is the balance equation. So having done that, we are coming to the end of the topic. Informations provided by a balanced chemical equation. What information does a balanced equation give us? 1. It gives the relative number of atoms and molecules of the reactants that take part in the reaction. 2. It gives the relative number of atoms and molecules of the products formed in the reaction. Number 3. It shows the ratio of the moles of reactants and the products. Then, number 4, it gives the ratio of the masses of the reactants and the products. Then, number 5, it identifies the reactants and products through their symbols and formula. And then, the last one, it gives the physical states of the reactants and products. Then, information that are not obtained or that are not provided by a balanced equation. So what are the information you cannot get from a balanced equation? 1, it does not give an idea of the feasibility of the reaction. So the equation cannot tell you whether the reaction can take place or not. That's what it means. 2, it does not give the heat changes accompanying the reaction. So it doesn't tell you about the enthalpy change of the reaction. Then number 3, it does not provide information about the speed of the reaction. So it does not provide information about the reaction kinetics. So that is it for today's tutorial. Always stay connected. In our next video, we shall be looking at the mole concept and stoichiometry of reactions. We're going to look at chemical equations and how to perform calculations on chemical equations. Play the video, take time to study it, and have a nice day. Thank you.